Hi, this is Melissa, and today my partner Forrest and I will be giving you a brief overview of the Go programming language. First, we'll take a look at the history of the language. Next, we'll look at its basic features. Then we'll go through a brief tutorial, and finally, evaluate the characteristics of the language to determine some of its strengths and weaknesses. So to start things off, let me give you some background on the language. Go was first developed by Google in 2007 by Ken Thompson, Robert Grismere, and Rob Pike. It was released as open source in late 2009, and in 2012, Go 1 was released. Prior to Go 1, Go's fundamentals were still considered to be in early development. But Go 1 defined the official language specification and standard libraries for the language. It also later guaranteed that all future releases of the language would be backwards compatible with that version, and created stability for the user base. Go was created because its developers had been frustrated with existing language options that were available. They wanted an easy-to-write language which could support fast, efficient compilation and execution, and which supported more modern features like concurrency. There were two guiding principles that they tried to follow while creating the language. These are simplicity, where they wanted the language to be clear, concise, and easy to write in, and orthogonality, which avoids exceptions to language's rules and would implement methods for each of its types. A few notable languages that inspired Go are the C family of languages, which it bases its syntax off of, Pascal and Modula, which influenced its declarations, and Limbo, which inspired Go's handling of concurrency. Go is a general-purpose language and is supported across multiple platforms, including Windows, OS X, and Linux. Some of its applications include networking and web servers, command line programs, and mobile programming, although right now that's a little bit experimental still. As far as its popularity over the years goes, Go was named 2009's Programming Language of the Year by the TOB Index, and it's currently rated as the 48th most popular programming language in use today. It maintains an active development community and will likely remain in use for years to come. Now that you have a general background of the language, let's take a look at its basic features. Go supports three programming paradigms: imperative or procedural programming, concurrent programming, and object-oriented programming. The imperative paradigm is based on changes of state, and Go supports this by allowing users to define variables and therefore a state. Structured programming is also supported in Go with the availability of functions. Concurrent programming is a paradigm based on executing operations in a simultaneous rather than sequential manner. Go was specifically developed with this in mind and provides routines for concurrent operations. Communication between these lightweight threads is enabled by the channel type. Object-oriented programming is not supported in Go the way that it is in languages like C# or Java. In Go, it is based on interfaces which are not explicitly defined on a type. Instead, behavior is embedded via the use of functions. There is no support for inheritance in Go either, and encapsulation is supported through exporting variables in packages. So now let's look at some data types in Go. Go's built-in data types provide enough power to build complex applications. Primitive number types include float 32, float 64, complex 64, complex 128, int 8, int 16, int 32, int, and int 64. Int is a 32-bit integer, but is a separate data type than int 32. There's also uint8, uint816, uint32, and uint64. Go also supports Boolean types with bool, and string types with string. In Go, strings are arranged by bytes, and like most languages, they are immutable. Pointer types also exist, and are denoted with an asterisk before the type name. The representative of null or none in Go is nil. Arrays in Go are always fixed length. They can be denoted with brackets before the type and are declared with their size. Slices can be used to represent dynamic arrays. They maintain a reference to a section of an array and are also denoted with brackets, but in the declaration of the slice. Next, hash maps are an associative array present in Go and can be denoted with brackets and value type. The keys in Go are not limited to strings. Record types in Go are definable with the type N struct keyword sequence. And the last data type we'll look at are channel types, which are unique types that allow communication between Go routines. Messages can go onto or be pulled off of the channel with the > operator. Now that we're familiar with those, let's look at Go's control flow. Go provides functionality for many of the same control structures as C or C++, but in simplified form. If statements are present in Go and are denoted similarly to how they are in C. However, parentheses are not required around the expression. The for loop is also present in Go, but unlike C, the while loop is built into it. Again, parentheses are not required around the expressions. And to use the for loop as a while loop, we provide only the middle expression. Switch statements in Go can be written with the switch keyword, followed by an optional variable and a block of code with cases. Variables passed into the switch don't have to be integers. And when a value is not passed into the switch, the case that evaluates to true is selected. Go programs can execute multiple operations at once using Go routines. The Go language also has select statements, which aid Go routines in the retrieval of messages sent via channels. They allow a Go routine to wait until a message is received on the specified channel. Now let's take a quick look at subprograms. In Go, we call these functions. Functions are declared using the func keyword, followed by the name of the function, its parameters enclosed in parentheses, a return type, and a block of code to execute. Functions in Go can also name their return variables. To return the variables from a function, return is used with no argument given. Similar to functions in Python, Go functions can also return multiple values. In fact, a common practice in the language is to return an error message along with a return value, as shown below. Functions can also be executed with the defer keyword used in front. This schedules the function to execute when its parent function returns its control. Finally, let's briefly cover object orientation features in Go. Go does not support object orientation as well as languages like Java or C#. Go does not have inheritance, but interfaces provide the ability for loose abstraction. Rather than explicitly stating them, a struct implements an interface and embeds the functions within it. Interfaces are defined like structs, but with the interface keyword, and embedded into structs by attaching interface functions to the struct. In this example, because we have embedded the eat function into the dog struct, the dog is implicitly recognized as an animal. Go packages provide a means to encapsulate data through exported variables. Exported variables resemble public variables in C++ or Java, but are not exported via an explicit export keyword, like in Node.js. To export a function or variable, the first letter in the identifier is capitalized. Identifiers that begin with a lowercase letter are not exported and are therefore private. And here's an example of a Go package. The sum function is accessible to the packages that import the math-utils package because it begins with a capital letter and is exported. The product function is not accessible to packages outside of the math-utils package in this example because it begins with a lowercase letter and is not exported. Next, let's go through a quick tutorial. In this tutorial, we'll cover how to write a function in Go, how to write the entry point of the program in Go, how to import a package, and how to print to the console, as well as how to use the Go command to compile a Go program. With this knowledge, you'll be able to write a Hello World program in Go for the first time. Go functions can be created by using the func keyword, followed by the function name, parameters in parentheses, return type, and body, as shown below. Go programs are structured within packages, similar to classes in other languages. The entry point of a Go program is the function named main in the main package. To declare a package, use the keyword package, followed by the name of the package, as shown below. Now that we're able to create a package and a function, we know enough to create the entry point. First, start with a package named main. Next, add the main function. Together, these create the point of entry for Go programs. Before we can print to the console, we first have to import the module that knows how to print to the console in Go. The FMT package built into the Go language contains the method println that does exactly that. To import a package with Go, use the import keyword, followed by the package that you would like to import, in quotation marks. Multiple packages can also be imported with a single import statement. Just put each package on separate lines and enclose them with a parentheses. Now that we have the FMT package imported, printing to the console is easy. The println method within FMT accepts a variety of arguments, including a string, and prints them to the console. To access methods within the packages, the dot operator is used, in conjunction with the package name and function name. The complete implementation of your Hello World program is comprised here in just 5 lines. Now we just have to compile it. The Go command line utility can be used to compile Go programs into executable programs. To compile a Go program with this utility, execute the Go program, followed by the build parameter, and the file containing the entry point of the program. For example, if your entry point was named main.go, you could use go build main.go to compile the source code into an executable program named main, or main.exe on Windows. Now that we've completed this tutorial, here are some great resources to check out if you're interested in looking further into the language.
Now that we know how to implement a simple program in Go, let's look at a more complex example. We designed Instant Forum. Instant Forum had a few main goals upon conception. Users should be able to post thoughts or questions and have other users comment on the content. And the content should also be pushed to listeners as soon as it was received by the receiver. Hence the name Instant. These features will allow a group to communicate efficiently with others in settings where vocal communication with everyone could be time-consuming, such as a classroom with a large number of students, or a conference with a large number of attendees. Instant Forum's technology stack incorporates Go for the server-side aspects, but the client-side components were developed using HTML, CSS for styling, JavaScript for the logic, along with the AngularJS framework, as it was a web application. Real-time client-side communication with the server was made possible by the Socket.io library. Instant Forum Server is comprised of two key components, the forum server and the web server. The forum server handles anything related to content insertion, deletion, or modification, while the web server handles the initial request and sends the response, including the client. The forum server for Instant Forum stores content within two slice data types, one for the current post contained within the server, and the others for the user that it logged in with their password. When initialization takes place, the server is configured to respond to the following events: connection event, the forum post event, a comment post, a login, or a delete. Each registered event plays an integral part of the server. The connection event sends a list of all current posts to the socket, and all socket events are registered to that socket. The forum post event sends that post to all sockets listening. The comment post event sends the comment to all sockets listening. The login event checks whether the user exists or not, and if it does, it checks if the correct password is given before providing access to the forum. If it is a new user, it creates them an account and provides access to the forum. The delete event verifies that the author of the post is wanting the deletion, and if it is the author that is requesting it, it deletes the post. If someone else requests it, it does nothing. The next key component in the Instant Forum server is the web server. Go actually provides an HTTP server in the net/HTTP package. Two steps are required to implement this web server. Set up the server to respond to the Socket.io path to use the forum server as the request handler, while just the generic / path to serve our static content such as HTML files, our style sheets, and JavaScript logic. Now that the forum server and web server are configured correctly, all that is required for us to do is to get the HTTP server to listen on our desired port. The forum can then be accessed on any modern web browser on the port provided during the configuration. Here we have the source code of our Instant Forum web app. The top three packages are dependencies used by the server. The static is the client for the web app, and the main.go file is the entry point for our program. Our main file begins with a package main declaration, followed by our imports of all our dependencies. Then is comprised of three main parts: the content of the users, which is a slice of posts and a slice of users; the initialization and configuration of the web server; and the initialization and configuration of the Socket.io server. Let's begin by looking at the forum server. It is a Socket.io server, so we initialize a new Socket.io server and save it. Then we register some events. To begin with, on a connection, we need a delegate function with a Socket.io socket that we can act on. Our first order of business is to join the socket to the forum room and emit the net posts event that sends JSON data to the client that will initialize the post for the new user. Next, the socket registers a forum post, a comment post event, a login event, the delete event, and a disconnection. Next, let's look at the web server. As we have defined the setup forum server, which sets up a socket.io server, we can use that and assign it to our server variable. Next, we tell the HTTP server to handle all requests with the socket.io path with this server. Next, we tell all the default directory requests to be served out of the file server, or this static directory where the client is held, with the CSS and JavaScript and the templating. Finally, we tell the HTTP server to listen and serve on the port provided to the function, which in the main function is 3000. And this start web server function gets the instant forum server up and running. Now let's start instant forum and see it in action. You can see by the logging message it's serving on port 3000. Let's log in with two different users so you can see that it actually does instantly come in. Now if one user makes a post, the other user sees it instantly. And if a user comments on it, the other one sees it instantly as well. However, you notice the deletion option is only given to the author of the post. If this user makes a post, the other one will not be given the option for deletion. Deletion occurs in real time as well. You can see all the logging messages present in the console window. Well, that's enough of an example. Let's get back to the evaluation of the Go programming language. And now we come to the evaluation portion of our presentation. We evaluated Go with the 4 evaluation criteria in Sebastia's textbook. They are readability, or how well developers can understand written programs in the language; writability, how easy it is for developers to generate solutions to problems; reliability, which has to do with the robustness of the programs produced with the language; and the cost, the time investment for the developer and the financial investment for the businesses that need to train the developer, since time is money. Now let's take a look at Go's simplicity and orthogonality. It was designed with these characteristics in mind, in fact. The only downfalls to this are the limitations that it poses to its grammar and feature set. For example, operator overloading is not available in Go, which can limit less intuitive uses of operators, such as subtracting with the addition operator, and increase Go's readability because of this. Some argue that this hinders what can be accomplished with the language and view the simplicity as one of Go's major flaws. On the other hand, the simplicity of Go's rules allows it to be very readable and compile very quickly. Control structures in Go resemble a more simplified set of controls than those found in C-based languages or Java. Writability can be increased as there is less for the developer to remember. However, readability can be harmed by the simplicity. For example, the for keyword in Go is the while loop, and a for without any expression following is a while true or an infinite loop. This is slightly less intuitive than many languages. The built-in data types in Go are also enough to support the development of complex applications, yet they lack major abstraction techniques and therefore make generic data types difficult to represent. As a result, programs in Go are more performant, but at a sacrifice to writability. Interfaces can mimic the abstractions, but objects of a certain interface must re-implement the logic, duplicating code. Go's syntax was designed to omit unnecessary symbols and reduce the overhead required to create programs in the language. It doesn't require parentheses around expressions evaluated by control structures, and semicolons are always implied at the end of the line. Semicolons can still be placed there, however, and Go programs will compile just fine. The limited number of keywords in Go increases both the readability and writability of the language. Developers using C-based languages or Java will have no trouble picking up the syntax. This also decreases the cost of learning the language. Although present in Go, abstraction cannot be utilized for code reuse like in Java or C#. Since Go has no inheritance, data types cannot be derived from a base class, potentially increasing the amount of duplicated code. Interfaces in Go do provide abstraction with the ability to perform the same operation on multiple types, but the operation has to be implemented for each of those types, duplicating code. Compared to Fortran 77, the writability of Go is greater due to the presence of data abstractions through trucks. Sebesta says a binary tree had to be implemented with 3 parallel arrays in Fortran 77. In Go, a binary node could be abstracted through a struct, and each left or right child could be accessed through the left member or the right member, increasing the writability greatly. Process abstraction is allowed in Go through interfaces and functions, however not in the magnitude provided by Java and C#, as they provide inheritance. The expressivity of Go has increased when compared to C-based languages. Go omits several unnecessary symbols that we have seen so far, such as the semicolon or enclosing parentheses around expressions that are to be evaluated in control structures. Expressions can also be omitted in the for loop and switch control structure. For example, let's look at infinite loops. An infinite loop in C++ can be represented with a while keyword, the true keyword enclosed in parentheses as the expression, and the code to execute infinitely. In Golang, you simply use the for keyword, omit the expression to evaluate, and include your code to execute infinitely. The if-else block in C++ can also be represented differently in Golang. In Golang, a switch can be used with an omitted expression, in which case the case that evaluates to true is executed. Go is a statically typed language. This makes compile time checking possible, which produces more performant code. Go's type system is also a nominal type system, which means the types are decided based on the name of the type. Structured typing can occur when interface types are checked at runtime. Another name for structured typing is duck typing, which some of you may already have been exposed to. Although Go provides compile time type checking, runtime checks occur for interfaces. Structured typing happens during these checks and is based upon what the object can do or the methods implemented within, rather than the name of its type. Unlike C#, Go has no defined exception types such as buffer overflow exception or invalid input exception, but Go does provide an error interface, which declares a function named error that returns a string. Information about the error is stored in the string, and corrective action can be implemented by the developer. Error handling techniques prevalent in Go fall back to the ability to return multiple values from a function. The most widely used error handling technique in Go is to return an error value from a function as the last returned value. The getMessages function returns the messages received along with an error message if one has occurred. When a developer consumes the function, it is the developer's responsibility to catch the error as such and check and see if any error has occurred. From there, the developer can choose to implement corrective action or halt the program. Aliasing is supported in Go via pointers, like in C++. Any data type can have a pointer. Slices, on the other hand, are present in Go, and they reference a section of an underlying array or the entire array. In Go, there is no pass by reference. Every variable is passed by value, limiting the number of aliases generated. Functions in Go that take pointers as parameters, however, can circumvent this limitation as they pass by reference. Languages that allow aliasing decrease reliability as they can have issues with memory leakage and dangling pointers. Go programs are garbage collected, and as such, the memory management is not in the hands of the developer. Even with garbage collection, memory leakage can occur because of available aliasing. The readability of the Go language is fairly decent. Go programs lack unnecessary syntactical symbols that are present in languages such as Java and C++, resulting in increased readability. Control structures, however, such as a common while loop, are less intuitive, being declared with a for keyword. But the ability to name return variables also aids to the readability of the language. Go programs are also fairly easy to write. The absence of unnecessary syntactical symbols also increases the writability of Go. Abstraction via interfaces provides some relief to the writability of it with generic actions. However, the absence of inheritance hinders the aspect of code reuse greatly, resulting in increased overhead to the developer. Go builds fairly robust programs as well. Compile time checking for variable types and runtime checking for interface types aid in the reliability of Go. All function parameters are passed in by value, eliminating the aliases when you pass by reference. Pointers exist and can still procure memory errors and unpredictable functionality present in any alias-enabled language. The overall cost of learning Go is not too expensive. C and C++ developers as well as Java will recognize a familiar syntax and design pattern with Go, resulting in an ease of learning the language. Go's program structure and package structure is different for those not used to it, however. Because Go is compiled to machine code, it is more performant than its interpreted competitors, but Go's garbage collection limits its performance compared to C++ and other languages where memory is manually managed. If we had implemented our medium program in C++, greater overhead would have been needed to create the communication environment between the server and the client, mainly in the form of syntax. Greater overhead would have been needed to create the web server as well, as Go provides a web server within its built-in library. The server would have been more performant, however, due to the lack of garbage collection in C++. This has been a brief overview of the Go programming language. We've covered a history and background of the language and a few of its influences, its basic features, setup, components, and explored some of Go's inherent advantages and pitfalls. The experience of learning Go has increased my ability to select a language based on the task at hand. Should you decide to take on the challenge of learning Go, my advice would be dive right into the code and play with the language. Try to solve previously solved problems with a different set of tools. Had more time been allocated for the Medium project, I would have separated the configuration of the forum server into a separate package, allowing for modularization and use in other products that need community communication. Information used in the presentation can be referenced on the next 2 pages. If you would like to learn Go, here are 3 resources that can help you get started.